Hello, my dear children. Today we are going to discuss introduction to Euclid's geometry. Okay, my dear children. During Euclid's period, the notions of points, line, plane, or surface, and so on were derived from what was seen around them. Okay, my dear children. Right. Euclid 325 to 265 BC is known as the father of geometry. He is known as father of geometry. He is credited for organizing all the works of mathematics then known into a logical representation in elements, which is a collection of 13 books. He wrote a book named Elements. It is a collection of 13 books. Okay, my children, right. Some definitions given in his book 1 of the elements are as follows. The first book of his written elements, these are the some definitions. See this first point. A point is that which has no part. He defined like this. Okay, my children, he defined point which has no part. And second one, a line is breathless length. A line does not have any breadth. He defined a line like this. A straight line is a line which lies evenly with points on itself. Okay, my children, these are all basic points in geometry. He defined. Okay, my children, like this. Next, a surface is that which has length and breadth only. He defined surface like this. Next, the edges of a surface are lines. The edges of a surface are lines. And a plane surface is a surface which lies evenly with the straight lines on itself. Okay, my children, these are all the some of his definitions given in the book 1 of elements. Okay, my children, right. Now we are going to discuss about axioms and postulates. What is meant by axioms and what is meant by postulates? Axioms and postulates are the assumptions that are obvious universal truths. Both are universally truths but are not proved. We can't prove it. Euclid used the terms postulate for the assumptions that were specific to geometry, whereas axioms are used throughout mathematics and are not specially linked to geometry. Understood this difference between the axioms and postulates, my dear children? Axioms and postulates both are universal truth, which cannot be proved, which are not proved. But this term postulates are the assumptions that are specific to geometry, whereas axioms are throughout mathematics. We can use these axioms for any branch of mathematics. Okay, my children, right. Now let us discuss the axioms of Euclid's axioms. See these axioms. Things that are equal to the same things are equal to one another. This is one of the axioms given by Euclids. Okay, my dear children. If equals are added to equals, then the wholes are also equal. Just like in algebra, if we are adding on both sides, same side, on both sides we add the same, the resultant equation also same. Okay, my children. Next, if equals are subtracted from equals, then the remainders also equal. This property also in solving the equations. In solving the equations, we subtract the same number on both sides. Okay, my children. Then the resultant number also equal. Next, things that coincide with one another are equal to one other. Suppose A is equal to B and B is equal to C, then we can say that A is equal to C. That is the meaning of this axiom. Okay, my children, right. The whole is greater than the part. The whole is greater than a part. A part means smaller, small part, small thing means, and the whole means a bigger one. So the whole is always greater than the part. This is one of the axioms. Next, things that are double of the same things are equal to one another. Suppose x and y are two things are there, two objects. If we double the x and y on both sides, we assumed that x and y are equal. If we are doubling the same quantities, 2x is equal to 2y. That's all. That is an axiom. The things that are double of the same things are equal to the one another. Okay, my children. Right. Next, things that are halves of the same things are equal to one another. Same like the above axiom. Understood, my dear children? These are the some of the axioms given by Euclid. Okay, my dear children, remember these axioms. Right. Now we are going to discuss Euclid's 5 postulates. We have discussed so far Euclid's axioms. Now we are going to discuss Euclid's 5 postulates. Okay, my children? Right. Now this is the first postulate given by Euclid. A straight line may be drawn from any one point to any other point. Okay, my children. We can draw a only one and one straight line can be drawn through two given points. That is the meaning of the sentence. If we are given any 2 points in a plane, we can draw one and only one straight line can be drawn. This is about the first postulate. Okay, my children? Right. See, observe this figure. Here P and Q are two different points in a plane. Then we can draw one and only one straight line can be drawn passing through these two given points P and Q. Okay, my children, diagrammatically we represented this postulate. Understood this postulate, my children? Right. The above result can be stated in the form of an axiom as follows. See this axiom. Given two distinct points, there is a unique line that passes through them. We have represented geometrically of this axiom. Okay, my children? Understood? Right. Now come to the second postulate. A terminated line can be produced indefinitely. Means on either side we can extend that line infinitely without taking an end point. Understood this point, my children? Right. See this diagram. Here M and N are the endpoints of the line Mn. Then we can extend this side right side and this side left side infinitely. That is the second postulate given by Euclid's. Remember these postulates and axioms given by Euclid's, my dear children. Okay, right. Now come to the third postulate. A circle can be drawn with any center and any radius. It means we can draw a circle on a plane by taking any point on the plane. Understood this point, my children? This is a third postulate. Okay, my children? Understood? Right. So see these figures. Here we have taken this point as center and we have drawn a circle with a radius 2 centimeters. Similarly, we have taken this point as center and we have taken radius 4 centimeters and we have drawn a circle. Similarly, here we have taken this point as the center of the circle and radius of the circle is 8 centimeters and we have drawn a circle with 8 centimeters radius. Understood point, my children? This is the third postulate of Euclid. Okay, my children? Understood? Right. Now come to the fourth postulate. All right angles are equal to one another. This is fourth postulate given by Euclid. All right angles are equal to another. Okay, my children, understood? We represent this postulate also geometrically. Okay, my children, right. See this diagram, my children. Here, this is right angle, this is also right angle, this is also right angle, this is also right angle. So all these right angles are equal to one another. Okay, my children, right. Now let us discuss the fifth postulate given by Euclid. If a straight line falling on two straight lines forms the interior angles that together measure less than two right angles on the same side of it, then the two straight lines, if produced indefinitely, meet on that side on which the sum of the angles is less than two right angles. Okay, my children, understood this postulate? We discuss this postulate geometrically, diagrammatically. Okay, my children, right. Now observe this diagram, my children. Here these two lines are given L1 and L2. These two lines are intersected by another line L. What is this line called? What is this line L called? Transversal line. Yes, this is intersecting these two distinct lines in distinct points, namely A and B. Okay, my children. Now, here A and B are said to be interior angles on the same side of the transversal, and moreover, the sum of these two angles is less than 180, less than two right angles. The sum of these two angles is less than two right angles. Then these two lines, if we are extending indefinitely, they meet this side. That is postulate given by Euclid. If the sum of the interior angles is less than two right angles, that side, the lines, two lines are produced, they will meet. Okay, my children, understood this postulate given by Euclid, my children? Right. Euclid's fifth postulate indirectly confirms the existence of parallel lines. Okay, my children, by Euclid's fifth postulate, we can confirm that the existence of parallel lines, whether the given two lines are parallel or not, with the help of Euclid's fifth postulate. Okay, my children, right. See here, my dear children, here the sum of these two interior angles is less than two right angles, means less than 180 degrees. Then the distance between these two lines, you see here, it is decreasing gradually. The distance between the two lines are decreasing. If you extend indefinitely this side, the two lines meet at some point. That is the fifth postulate given by Euclid. Understood, my dear children? Right. See here, two equivalent versions of Euclid's fifth postulate. What are the two equivalent versions of Euclid's fifth postulate? Two equivalent versions of Euclid's fifth postulate are as follows. For every line L and for every point P not lying on L, there exists a unique line M passing through the point P and parallel to line L. It is also equivalent to Euclid's fifth postulate. Similarly, two distinct intersecting lines cannot be parallel to the same line. This is also equivalent version of Euclid's fifth postulate. Understood, my dear children? Right. Okay, my dear children, thank you. Before going to start the exercise sums, these are the concepts of the chapter Introduction to Euclid's Geometry. Once you go through the textbook and we start the exercise sums tomorrow. Okay, my children. Before that, write the notes and submit. Okay, my children. Right.